All right, welcome back to Burt's Basics, Box Elder High School Medical Anatomy and Physiology. Today we are covering one of my favorite topics. It's also one of the most challenging, especially if you've never taken chemistry, which is the basic idea of bonding, chemical bonding. If you really want to get good at anatomy, you can't bypass the chemistry part. So let's do our best and try to learn as much about bonding as possible. So here are the things that you need to know in this unit. It says cation, anion, which is not that bad, but the trick is you have to know the difference between ionic, covalent, and hydrogen. Now I'm probably going to go above and beyond what you need to know here. You got to remember though, I got my degree in biochemistry. I love chemistry, and the stronger chemistry background you have, the better you'll be at your future with medicine and CNA and RN and farm tech or whatever you want to go into. So let's start with bonding. Now if you really want to get good at bonding, there are two things you have to know, okay? There's two things you got to know first, and then bonding falls into place. The first word is the word valence. Now, I'm going to say valence all the time in class, and you have to know a little bit about these. Now, in our last video, we talked about how these electrons fall in these things called rings, clouds, or orbits, or shells. Valence are the electrons on the top floor, or the outermost shell of the building. So if you look at this atom over here, you can see that once the shell gets full, it must go to a second shell, and a third shell, and so on and so on. Now there's some tricks that you'll learn in chemistry and AP chemistry as you continue on. The first shell can only hold two. So if you have more than two electrons, you need more than one shell. But the subsequent shells tend to hold 8. So then we hold 8 and we keep on going. And then they get even bigger. As you can see, this next shell holds a ton. However, the valence shell is the electrons on the outermost shell. Now, since this is a basic class, we are going to stick with these elements at the beginning of the periodic table here. And this is the easiest way to figure out how many valence electrons they have. If you're in family 1, over here, you have 1 valence electron. If you're in family 2, you have 2. We don't care about these yellow. They're called transition metals. They change their charge and their electrons all the time, so we're skipping them. Over here, boron, that's family 3. That gets 3 valence electrons, okay? Carbon's 4, they get 4. Nitrogen 5, they get 5. Oxygen 6, 7, and noble gases are 8. And so whenever I see valence shells, it's just the electrons on the outermost floor. Those are the ones that are going to be responsible for bonding. The second thing you need to know, okay, is if we look at this, the last family is your noble gases. Actually, I guess there's 3 things you need to learn. No, I lied. These are called your noble gases here in family 8, and you can see why. If you look at them, they all have 2 on their first shell like they're supposed to, and then they should all have 8 on subsequent shells like they're supposed to. But if you notice, helium only has 1 shell, and there's 2 on there. So that means the shell's completely full. If we look at neon, he's got 10 electrons, 2 on the first shell and 8 on the next shell. He can't hold more than 8. So his outer shell's completely full. And then you can see argon. I'm not going to beat a drum, but you can see argon's outer shell's completely full. The goal in life of every atom in the world is to have a full outer shell. If you are, you become stable. That's why these guys are called noble. Okay, if someone tries to bond with neon, he's going to be like, get off me, clown. I don't need you. Okay? The next thing you need to know is the coolest, weirdest periodic table you have ever seen. This is called electronegativity. Now, remember, this what happens in a video stays on a video. But if you get home from a date and your roommate asks, hey, man, how was she 1 to 10? That's a trap. Okay? Don't ever answer that question. Okay? Because if you call her a 2 out of 10, she's going to hunt you down and hurt you. Okay? So that's something we never ask. But elements on the periodic table are very similar to that. They have a hotness factor to them. And it goes from 1 to 4. We call that hotness factor electronegativity. Electronegativity is the ability or the strength you have for electrons to come to you. So the electrons run to you. So if we look, check out fluorine. Oh my goodness, it's a 4. It's the hottest element on the periodic table. Check out sodium over here. He's a 1. That's pretty ugly if you're in the world of atoms. So every element on the periodic table has an electronegativity. So now let's talk about bonding. Most atoms do not have a full outer shell. So they're going to do anything in the world to become stable. And remember, to become stable, we have to have a full outer shell. So let's look at sodium. He has a lot of electrons, but I only care about the outermost floor, which is this guy. He has 1 valence electron. Just 1. If we look at chlorine over here, he has 7 valence electrons. So he doesn't have 8 either. So both of them right now are neutral. They don't have a charge, but they are unstable. So what do you think is going to happen here? If this guy has 1 and this guy has 7, this guy wants 8, so then he's going to steal or take. which is the number one word or two words you have to know with ionic bond. They steal electrons. They take electrons. Gimme, gimme, gimme. Mine, 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 mine. Me, 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 me. The problem is, look what happens when they do. As soon as chlorine takes that electron, check it out. He now has 8 in his outermost shell, and he looks like a noble gas, but he's not, because he still has his chlorine amount of protons. But he did gain an electron. Since he gained an electron, he is now negative. He's stable, but he's negative. Now, when I first learned chemistry, I thought sodium got screwed here, and I never really understood the why. I thought sodium, man, he just lost his 1. That's kind of horrible. You know why he lost his 1. He lost his 1 because sodium is a 1, and chlorine's a 3. So this poor electron here in pink, he doesn't want to stay with sodium. He's a 1. He wants to jump to the 3. So he jumped ship over to the chlorine. And now, since he left, sodium's positive. Now here's the trick. Check out his outer shell now. It's completely empty, which means it is now gone. It's no longer there. And his inner shell already had 8. So now he also, too, looks like a noble gas. And congratulations, you just created an ionic bond. Now, the word ion means an element that has a charge. Sodium is now positive. He's an ion. Chlorine's now negative. He's an ion. The problem is I can't call them both ions because one's positive and one's negative. So that's where these words come into play. A cation is the term referred to a positive ion, where an anion is a term we're going to use for a negative ion. You've probably heard these words before. In batteries, we use them all the time. Batteries have a plus and a minus. We call them cathode and anode. So these are your ions. Now, what happens when I get a positive and a negative together? They like to stick together because they're opposite charge, and you just made salt. If you guys understand this little tutorial, you can now do any bonding in the world. Because in ionic, they're going to take, steal, throw, move electrons until they can become stable. So the key word on ionic bond is they're going to steal it. Okay? Now, if you're a math person, which some of you are, you can actually do this mathematically. Sodium has an electronegativity of 1. Chlorine has electronegativity of 3. If you subtract those two, 3 subtract 1 is 2. In general science, if you have a difference in electronegativity of 1.7 or greater, you will always be ionic. These guys are always positive, and you should know why. They're all positive because they're all ugly. All the electrons are leaving. This side of the periodic table tends to be very negative because all the electrons are running to it. So we have our metals are losers. Okay, they're all positive. Non-metals over here are winners. They're all negative. Now, you've got that down. So now let's do our next trick. Unfortunately, you can't steal all the time. So sometimes you are forced to share. Oh, hold on one second. The joy of filming videos at school, okay? Unfortunately, you can't steal them all the time. Sometimes you are forced to share. And if you have to share electrons, they're called covalent. So let's talk about covalent bonds really quick. There are 2 types of covalent bonds. There's polar and there's nonpolar. So let's start with polar first. If you look at oxygen, he is in family 6, so he has 6 valence electrons. But he's not happy because he wants to look like a noble gas. He needs 8. He wants 8. He's begging for 8. So here comes a hydrogen floating by. Now the trick is, if you look over here in my notes, oxygen is a 3.5. Hydrogen's not that ugly. He's a 2.1. So even though oxygen wants to take them, he can't. He's not hot enough to take them. So instead of taking, they have to share, which is called covalent. The problem is he wants 8. Hydrogen only has 1 to give. So right now I have 1, 2, 3, 4, 5, 6, 7. So what happens is another hydrogen comes along, and now they have 8. So if oxygen shares these 2, he becomes stable. Hydrogen does too, because remember, hydrogen, only the first shell can only hold 2. So if he borrows 1 of oxygens and 1 of oxygens, everyone is happy, and congratulations, you've now made a compound of water. Now, anytime you draw water, it's going to look like this. And I know this sounds really weird, but if you look at it, they are sharing. But I never, ever, ever said they had to share equally. So if you look at this, oxygen is hotter. He's pulling the electrons himself. So he gets this, I call it the snaky. Do you see this little snaky guy over here? That means a kind of or partial negative charge, because the electrons are generally here with him more often. That makes hydrogen have a partial positive charge because the electrons aren't with him, but they're still sharing. So this is not ionic, okay? That's why you got this negative naked, okay? So let's go back really quick. In ionic, what happened? The electron jumped ship to never return. In covalent, there's 2 types. In polar covalent, they are sharing. They're just not sharing evenly. This allows water to do everything on the planet. So since water now has one side that's slightly negative and one side that's partly positive, it can stick to everything. So in more chemistry, you'll learn a hydrogen bond. A hydrogen bond is when the positive of a hydrogen of a polar water molecule sticks to something negative of the other compound. Now, there are some rules. It has to be certain atoms, but water is amazing at sticking to anything in the world that has a charge. If it has a charge, water will stick to it, okay? Sometimes we have things that don't have a charge, which is my last one. Nonpolar covalent bonds. Now, they still say the word covalent, so they're still sharing. The thing is non-poles. They call this a pole, water, because there's a negative side and a positive side. What if two of the same elements come together? Who's hotter, chlorine or chlorine? If you're the same element, there's no pole. If there's no pole, they share perfectly evenly. In class, I always joke around that you want to have, there's three types of relationships. There's non-polar, polar covalent, and ionic. Most of you are going to be in an ionic relationship where one person takes everything and the other person gets nothing. Some of you are going to be in a polar covalent where you share, but there's one who dominates the relationship. Your goal in life is to have a non-polar relationship where you guys share perfectly evenly and are equally yoked, I guess you could argue. Okay? So if you look at this picture, oh, just kidding. Let's go to this picture first. This should make perfect sense. Ionic, C, electron jumps, creating positives and minus ions. This will be my cat ion. This will be my negative ion. Now, can I give you the hint on cat ion? Cat has a positive in the middle of it. So just remember, cat positive, cat ions are positive. In this one, they are sharing. It says covalent. They're sharing. But you can see chlorine has got more of the bubble because the electrons are naturally pulled his way. So he's kind of negative, where this guy's negative, positive. In non-polar covalent, they share perfectly evenly. Perfectly evenly. And the number one example of a non-polar compound in the world are fats, which now explains something you've already known. Water struggles with fats. Because water hits a fat and he's like, stick, but there's no charge on a fat, so water bounces off. Now, we use the word hydrophobic and hydrophilic, but I don't like those words because hydrophobic means that fats are afraid of water. They're really not afraid of water. They just don't get along with them. They just don't stick. Okay? So, guys, that is your summary of bonding. You guys did a very good job. That was a very hard lesson. Sorry the video went a little long, but I think it's important enough to spend some more time on it. So, get ready for the wickedest quiz you got. This quiz is hard. So the answer key is coming up next. Go ahead and pause it. Try to answer these questions. If you can knock out all 8 of these, you are now beginning on your pathway to being a superstar in the world of bonding and chemistry. Thanks for watching Burt's Body Basics, and I look forward to you coming back.